Hello. Today we would like to solve this question, this exponential equation question. Now, from the question, what we have to do is we have to try singling out the 3 exponent x. So we can rewrite it as 3 exponent x plus 243 multiplying 1 over 3 exponent x or minus 36 being equal to 0. Now, there's a reason why we express this 3 exponent minus x as this, because we know that in indices, if you are having a exponent minus x, that's the same as 1 over a exponent x, something like this. So that is how come we had this. So after doing that, the next thing you have to do is represent it by a variable of your choice. So we can let's say, any variable of our choice. So let's say y be equal to 3 exponent x. Now, wherever that we see 3 exponent x, that is this side and then this side, we are going to substitute y there. In that case, we are going to have our y plus 243 being multiplied by the 1 over y minus 36. That is equal to 0. Okay, so this is going to give us our y plus 243 over y minus 36 being equal to 0. There's a fraction, that is this particular one. So we try taking the denominator and then multiplying through. So when we multiply this by the same y, we are going to get our y squared plus 243, because it's like we are multiplying this by y. So y times this, and then this one 2 times y. Everything times y. Okay, so that is how come. All right, so this is going to give us minus 36y is equal to 0. Now, if you look at the equation that we are having here, this particular equation, it's now quadratic equation. Okay, so we need to solve this quadratic equation. And this particular quadratic equation can be solved using any of the methods, either the factorization method or the completing of squares or the general quadratic formula. But I think this one, we can use the factorization method. So let's try that. It was y squared minus 36y plus 2 for 3 being equal to 0. We can use two numbers in which when we multiply, indeed, we get these 2, 4, 3, but when we add them, we get a minus 36. Okay, so we can use negative 27 and then negative 9, because when we multiply these two numbers, it's going to give us positive 2, 4, 3. All right, so we are now going to write y squared minus 27y minus 9y plus 2, 4, 3 being equal to 0. We take the first two, we factorize. So we have y being a common factor. So we are going to get y minus 27. We take the last two, the common factor there is minus 9. So minus 9, we are going to get our y minus 2, 7. Okay, being equal to 0. In that case, we are going to have our y minus 27 being common. And again, y minus 9. Okay, and this will be equal to 0. Now we are having two linear factors multiplying and they are all being equal to 0. If that is the case, then it means that y minus 27 will be equal to 0, or the y minus 9 will be equal to 0. Okay, so in this case, we try solving for our y. And we are going to get our y to be equal to 27. And then for this side, we are going to get our y to be equal to 9. But the question, we were not solving for y. If you look at the question, we were solving for x. Okay, the question wants us to solve for x. So what we have to do is to bring back what y represents. But y is equal to 3 exponent x. If that is the case, then from our first value for y, this particular one, we are going to have 3 exponent x being equal to 27, which implies that we are going to get 3 exponent x being equal to 3 exponent 3. So this implies that x is equal to 3 per exponential equations, a situation whereby the bases are the same. We equate the exponent. So x is equal to 3. We again pick this particular value, y being equal to 9. So again, 3 exponent x, that is the y, is equal to 9. and the 9, we can rewrite this as, again, 3 exponent x being equal to 3 exponent 2. Therefore, we can see that x will be equal to 2, all because the bases are the same here, so this x will be equal to 2. All right, if that is the case, then our final answer, that is the value for x, we're going to get our x being equal to 2 and then 3. Okay, so thanks for watching this video and don't forget to subscribe. Bye bye.